All right, welcome back, generals, to another Let's Fix Generals 0 hour. Last video, we have been progressing with some code here. Yeah, before we continue that, I just saw that there is a new comment here. Hardy is asking, what are you doing exactly? 3 minutes ago. Just in time. That is a strange question. I mean, you see exactly what is being done in the video from start to finish. Like exactly what I do is exactly visible in all videos. So I don't understand this question. The answer is in the video, I would say. If you would watch the video, you would see what I was doing. Obviously, you need context. Like if you don't understand what is happening in this video because you don't understand the context because you're missing the previous video, then that's because you don't know the context from the previous video. But I don't give a summary every video of what I'm doing. Like I don't exactly give a summary of all the things I did before to give like a complete overview of what we're doing. It's a development. We develop. That's it. All right. So let's try to. So what did we do? We added the options, right? Here, these things, options. Yeah, we added this stuff here. And this stuff. And command line or type. Okay. Talking about comments, I also notice that there are too many people that join discussions without doing the homework. Like they write things. I mean, it's okay to be curious and ask questions, but it gets weird when people join discussions and they make statements that are outlandish and then counterproductive. And I don't know. It doesn't happen so often, but it happens sometimes, and then it's cringe. So I think it's always better to like get a bit of an overview of what the things are about that we look at, and then join the discussion or just ask questions. Because typically, if someone is working on something, if someone is working on a pet project, then they typically have domain knowledge over this stuff, right? Because they already put thought into things. right? So it's difficult to challenge someone who has spent significant amount of time doing something. Of course, if you have as well domain knowledge in that thing and can challenge some things, then yeah, that makes sense. But then I assume that those, and I think I do, that these people, they will approach it in a professional manner without being competitive and going into discussions with good intentions, right? But when it comes to gamers, what gamers often do is they take a position on something based on feelings or opinions or half-baked truths, whatever, and then they manifest this position, and then they become competitive and defend whatever they think is right or wrong. And then it's just a non-productive dialogue. Yeah, this happens in forums. It doesn't so much happen on like private spaces where you only get like the actual developers who know what they're talking about. There it's smooth sailing. But yeah, as soon as you invite the public, and there will be randoms that don't know what they're talking about, then yeah, discussions can be non-productive. Okay, so output file. Okay, so basically here we just made it destruct. But we could also do. No, it's fine. It's fine. Options. Hold on. Can we clean up the header maybe in our main file? We need the runner. Do we still need util? No. We need version, and we need runner. That's fine. Does runner include options though? It does. Then that means we can remove options here. Just have runner. Do we need file system? We don't. Remove that as well. Do we need IO stream? I'm not sure. IO stream. Maybe we can remove that. Do we need strings? I think that was used for STN case. I think we can remove that as well. Let's see. Oh no. Okay, that's what IO streams is used for. Okay. Okay, removed all this and that. Set from command line. Okay. Command line options. Yeah. default command line options. Add the options here. I added this. Yeah, I think that's all we need for now. Okay, let's move command line option create type to create struct for command line options and pass that to the imgui app. Create struct for command line options and pass it to the imgui app. Yeah. Good, and let's stash the other changes and see if that's still compiled. It does. Good, then a stash pop. And good. Then next step. Last video we were thinking about the open file dialog, which we wanted to clone from imgui file dialog. File dialog. It was this one, right? Demo app branch. Demo app. Oof, it's pretty big. Oh, holy shit. That is massive. 5,000 lines of code for a file dialog. Okay. Well. So the question is, how do we get this thing? Open dialog, display. Air action. How to build the sample app. You need to have OpenGL. It's just for the sample. Yeah, but how do I add this thing to... How do we add this thing to our project in CMake? There's not a up-to-date zip file here. How about we fork that thing? Yeah. And then we create a new release. Let's create a release. How did he do it? Version. Oof. Let's just put a date. 2024 11:05. Okay, publish release. Okay, and that creates us this thing here. Then we can copy the address, and then we go to which kind of populates. Then we simply here put this. let's create a new CMake. Imgui file dialog dot CMake. GUI file dialog. And then we go to our CMake list and we put here GUI file dialog. And here GUI file dialog. Then we compile that. Okay, then we go to imgui file dialog dot CMake. Here. Then we take this thing here and we put this here, imgui file dialog, and then let's run this first, see if that downloads it. I think it will. Let's see. Yeah. Okay, and that gives us a CMake list here. And I wonder, can we just pick it up or not? Project imgui file dialog. Add library. Yeah. CMake includes other CMake lists. Includes, okay. Add subdirectory. I think that's the one. So let's try here, add subdirectory. Populate imgui. Let's call this file dialog. Add subdirectory imgui file dialog. And then we should have this thing here and can use it in here. 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 File dialog. think. I'm not sure. Let's run this. Let's see what happens. Okay, we got an error. Cannot open include file imgui.h. Yeah, okay. Okay, so the project is here. Imgui.h. It's okay. CMake minimum projects. Target include directories. Current source there. Yeah, okay, so this thing doesn't know where imgui is. How do we tell it then? I don't know how we do this. Oh boy. assume we have to set another of these outside. So we go here and oof. Include imgui cmake. So imgui here, imgui. Public. Right. Yeah, okay, so I think what we need to do is we go to imgui, this one, and we do target include this private, and then we put imgui, right? Let's go back. Oh. Here, yeah, imgui, private imgui. Why is this public? Ah, because yeah, that's correct. So private and then just imgui, I think. Yeah. Maybe. Let's see. Yeah, that compiled. So does it also mean that we see this thing here? Let me see. If we go to our app here, can we do include imgui file dialog? Yeah, it sees it somehow. Okay, great. Yeah, let's put that here for now. Okay, good. Do we need anything else? Okay, I would like to test what happens. Does it work just fine if we remove this again and just refetch it? Let's see. Failed. Okay, that has failed. Cannot open include file. No such file directory. Okay. So I suspect we have to put here imgui file dialog. Fails. Okay, that's quite aggressive fail here. The source directory imgui file dialog does not contain a cmake list.txt. It contains nothing. Yeah, why not? Yeah, I'm not sure what's going on. Do we have to call this make available thingy? Populate, make available. Source dir, imgui cmake current source dir. I still don't know what that thing is. I wonder if we can just omit this. Cmake current source dir. Let's Google this. See what it means. The path to the source directory currently being processed. The full path to the source directory that's currently being processed by cmake. Current source dir. So I assume it's a file that the cmake file is in, or not? I mean, this is not really. It doesn't help much. Currently process cmake txt. I see. So it's like the yeah, it's the same as this. So yeah, I think we can just append it here. So this would allow us basically to move this imgui cmake to a subfolder. That's my understanding. But it's not strictly necessary. Does a Dia SDK use that? Not really, because it does something different. So, okay, I expected this would work, but it doesn't change anything. Okay. No, that's still errors. Fetch content. No content details. Okay. Let's Google for this one here. Fetch content populates. Self-contained call, which can be used to perform content population as an isolated operation. It is rarely the right command to use. Projects should almost always use fetch content declare and fetch content make available. CMake script mode is part of implementing some other higher level custom feature. So I do wonder, should we change it to declare or not? I don't know. So we do it here, but this one uses different things. Okay, let's see what happens. We go to here and we say declare that. Then what happens? Error. Yeah, so somehow, oh, now it actually got the files, yeah. But it still fails overall. Add library cannot create targets because another target with the same name already exists. Okay, let me delete this folder once more. I would like to see if it now actually gets generated to begin with. And download it. No. Okay, so that did nothing. Let's run it again just to make sure. Does nothing. Okay, then let's get it back to populate, which apparently is almost never the right thing to do, but we do it. Let's see. I don't know what the problem is. It worked once and then it somehow stopped. Okay, but we use this also here. And it worked. Why is it not working here with this? So if we comment out this one, what happens? Let's try that. Clearly that is accessible. I don't know. It worked once, download it, but now it doesn't download anymore. And the question is why? Yeah. It no longer downloads that stuff. And I have no idea why. It did it once. Why is it not doing it twice? Do we need to include fetch contents? I don't understand. Doesn't change anything. It somehow does not work. Let's Google for this. Populate does not work. Populate, make available. Declare. Okay, let's try again, declare. Let's see what this says. Also errors. That's sad. I don't understand. It worked once and then it stopped working. Do not use. This is done automatically. I don't understand. It worked 1 minute and then it somehow broke, and now it doesn't work anymore. We have CMake, right? Yeah. No. CMake. Configure. Why does it take so long? What is CMake doing? What is this? Okay, for some reason it's now here. Make available. Two fails. Okay, let's put this one back. Download extract timestamp option. Let's see this. Name content options. Okay, so I assume it means we have to put it here. Download extract timestamp. And I guess we should also put it here. Let's see. Figure. Okay, seems to be gone now. Let's remove this. Okay, so I suspect that this is not correct. Let's just assume it's correct. Yeah. I don't like the CMake stuff. It's always a journey. Okay, but it compiles, so it seems it's correct. Okay, let's test that file dialog. I think there was an example here somewhere here. Draw GUI. Let's see. CMake. ImGUI app, where is it? Here. Okay. Here. Okay. Do I need a window or can I just draw it here? I don't know what happens. Let's see what happens. Let's see. Take that away. Okay, debug, open file dialog. And that is okay. That's a 5,000 lines dialogue. Choose file. Okay, we are in our current folder. Okay, so that's good. Okay, it's actually not too shabby. Okay. Actually, that's pretty cool. Yeah. Can you select multiples? No, just one. Yeah, but that's okay for our purposes. And then you click OK. Okay, that works. Yeah. Yeah, I think that's good enough. Yeah, I think we just need it for like selecting the executable and the PDB. So it doesn't need to be fancy, but it looks like it's good enough. Yeah. Good. So we have a homegrown file dialog. Everything is custom. Everything's custom. Well, the thing is, this has to be custom because the UI is meant to be usable on any in any application. Like you can render this in a game, in a video game. You could render this UI. So you could have a full screen app and then have this UI running. Click on choose file, and in the game you would see this dialog. Right? That's why it's custom. It's not opening the native Windows dialog, platform dialog. Yeah, I think that's cool. I like it. All right, then you can click cancel. Okay, good. Then let's let's put a private show demo file dialog. File dialog. The voids file dialog. And we simply put it down here. GUI app here. Okay. And then we put this guy here. Okay. Short demo. Short demo window. Why do we have a boolean for this? Do we need a boolean? Let's just put it in here, next to this one here. Oops. Okay, also looks simple enough to use. Okay, so we got the demo here, and yeah, good. All right. Good. And will be compiled out and release. Debug. Yeah, how about we just put it here for now? Yeah. Eh. Okay. I don't think we need it for long. We can probably remove it in the future. Were you satisfied with debugging in Visual Studio? What is this question? What is this question? Yes. Okay, I don't want to take a survey. That's stupid. Okay, then let's do show app. Yeah, let's do our entry function will be show app, and then we trickle down from there. Show app. Yeah. Good. mgui app. Show app. Okay. Yeah. Okay. And then from here we can start adding all sorts of windows. Okay, but the question is, okay. mgui app. Okay. Yeah. mgui app. Okay, so when we click buttons and do things, then all the logic that does things needs to run on another thread or multiple threads. We can't do calculations within this app, right? Because then it would just hang. Like we click a button and it does something, it will hang. So we definitely need at least one worker thread that does things as we instruct it to do things. So Okay, I wonder if we if there's some library we can use to help us with threading, like a job system. C++ job system library. Job system. It should be simple. Blue Fedora job system. Job. So you pass a lambda. Three stars. Okay. Game job system C++ 20. We currently have C++ 17. Schedule lambda. Schedule. Okay, do we have a C++ 17 job system? Basic job system. Okay, that's just one header. High resolution clock is not something one should use, according to the author of Chrono, if I recall correctly. One should always use steady clock. But it's not wrong. It's a resolution clock is there. Okay, so I like that. Seems to be pretty simple. I like having one file header. But there's no code sample. There's a test. Worker count. Okay, you can push the workers. Job manager. Parallel jobs. What is this? No idea. Job chain builder. Do, then do, 1K jobs in parallel. But the advantage, if we use jobs, the advantage would be I don't know. My hope would be that we can run a lot of processing in parallel, essentially. We just, like, for example, have one job per function. It would require us to rewrite a bunch of stuff, but maybe it's worth it that everything is jobified. Because it would allow for the entire content to be built like as we go. Like you could kick off the jobs and it starts doing things, and at the same time you can use the UI to already inspect things that finish processing, you know. If our whole data supports that kind of thing, currently it does not, right? Like right now, PDB is one job, complete job, and then let's look at it. So if we go to runner, like all the things we have built currently, let me see, runner. So you go to process exe. We'll add symbols, PDB symbols. Okay, so the we need to think about this. Okay, so right now the design of the entire tool is to just sequentially plow through the data, right? One thread, we have the executable, the PDB, we read through the executable, get the data. Okay, but this is one task, it's fine, it's fast. Okay, then PDB. This one is a bit more complex, depending on the size. So it does a lot of stuff there. Let's go to our PDB reader. So there's this read function, loads, and it will load data from PDB. Data, open session. Open a session for querying symbols. Yeah. Oof. How do we implement this? So let's say we have read the PDB once. Yeah. Everything is in memory, all the symbols. And then we update the PDB. So we need to reload it. The way to do it right now is you call this read the second time, and that will purge. That will purge all the data that is currently there. Right? It's here. So read symbols. Here it will clear everything. And then we just recreate everything. So this is really expensive, especially when the PDB is large. Oof. Yeah. Okay, let's look at something else first. This is hard. This is a hard problem. Okay, so PDB aside, what about runner? So if we go to if we go to here, this build function matches. Build function matches. The thing is, we need to get all the data fresh from the PDB because we don't know what has changed. And something will have changed, like the codes, the source lines, function was added or removed, instructions, addresses change, right? So anything can change. So we have to rebuild the whole thing. There's no other way. Well, you could, you could probably do tricks, but then those tricks could backfire. So it's probably better to like just have a really high performance code that does everything fast. The way we have it right now is not fast. It's okay, but we don't utilize threading, and as long as we don't do that, it's not the max we can get out of this. But doing it multi-threaded is not very easy with the way we currently have it set up, because everything is organized in linear vectors. So build function matches, for example, we runner. Okay, maybe I'm thinking already a little bit too far ahead. Maybe we should first implement it in a just on one thread. Okay, let's go one function up. Build function bundles. What does that do? Function bundles. Build bundles. Yeah, this one is probably pretty fast. Yeah. I think what we should do is, yeah, I think what we should do is, for now, we implement everything, like we have the UI on our main thread running, and then we have our execution thread, whatever, that does all the building, like reading the PDB and building all this comparison stuff here, right? And that will take a certain amount of time already. Now, we have a relatively small data set right now. The PDB is rather small. There's not much in there. So it doesn't build all that much data. But once more and more functions are being added to the PDB, this will slow down over time. And then what we should do is we should take a profiling of that and see which sections of this are the slowest, right? So, for example, I expect that this here will be slow, right? Building, disassembling all the functions here, right? This could be quite slow. And then, yeah, we would have to identify what is slowest and then think about strategies to speed this up in ways that, so for example, we could say we have multiple jobs and then we give them ranges of these, right? So one thread does an eighth of the range and the next as well. So all threads have the same span of work and they can just do it all in parallel. And then that may work. Yeah. I guess for the disassemble, it's probably easy because this looks pretty simple because all these things are isolated, right? These things are all isolated. But when we have to build containers, it can be a bit more tricky, but that can be mitigated by just building subcontainers. And then at the end, after all jobs are done, we combine the subcontainers into one big container. So we would need merge functionality for certain things, which is tricky because our data is built with indexing. Like, where do we have an example? Function matches. Like this one here, for example, match bundle matches, right? So this one is indexing this, this, right? This is indexing this. But I think this can also be solved because when you have where's this build? Function matches. Yeah, okay, so this thing exists, and if you were building the function matches, you would give all these read-only function matches, and then it would build these bundles, and you can create these all separately. Yeah. Okay, so this is not a problem. So we can jobify a lot of things here, I think. Yeah. Yeah. In our runner, I think we could Shopify a lot of things without too much complications. So certainly the bundles, the disassemble. What about the function matches? This one is a bit more tricky because we got this map here. Yeah, this one is tricky. But maybe this is always fast enough. I mean, we do have a hash map here. Yeah, we will need to see in the profiler like how slow are the slowest things. My assumption is that passing the PDB will be slow and the disassembly of the functions will be slow. That's the two things I think will be the slowest. This one and the PDB. And the other things probably not as slow, but still could be consumers. Yeah, okay. So I think the plan is for now, we build the UI with functionality on. So the UI runs on threads, main thread, and the runner will run on a worker thread. And we won't jobify anything on this worker thread. It just runs like from start to finish. So like there will be a button in the UI and you say load or do this, process that, and then it will do it in one swoop. Can you cancel it? Yeah, we could add cancel functionality by just have checks here and there where you say if cancel, then stop the work. Yeah, so we can cancel. Yeah, I think that would be the easiest for now. Just one thread that does all the processing and the other thread does render the UI. Yeah, and then there will be a synchronization between these two. And so this is how we build it. And then if we then identify slow things, then we think about, okay, how can we further optimize the processing so that the UI gets the data sooner, if it makes sense. Yeah. Okay, I think that's a fair plan. Yeah. Okay, I suspect that some things will be easy to jobify, others hard. The PDB reader, I think this is hard because I'm not sure how the DR2 API will react to doing things on different threads. Like, what happens if you read on two threads or release things on two threads at the same time? Like, is this legal? I don't know. Maybe we would then research a bit, but actually we can do that now. Let's see. Bookmarks here. Here. Let's go for multi-threading. Multi-threads. Let's search for multi. Read multiple. Let's search for DR2 multi-threads. Debug interface access multi-threads. Doesn't really give us any results. Yeah, I don't know. I would have expected a little bit of Intel, but I don't know what to search for here. It gives us a reference, what you can do with it, but it doesn't tell you about any warnings regarding multi-threading. And I assume that there are things that will break if you use it in multi-threading. Maybe. I don't know, maybe it's fine as long as you always like the problem is we don't know what the internal state is of these things, right? So let's say we go to PDB reader. Like for example, you call we call find children, right? And we get this thing here, p-enum compilance. We don't know what's behind this interface. Like, can you process this thing on multiple threads? Probably not. Maybe not. Maybe you can, maybe not. Maybe all these root things need to be created on one thread and then just used on there. Like every thread would have its own PDB reader and read things, and then would be done and then merge the results together. I don't know. Well, it sounds complicated. That's the problem if you don't know the data behind this. If you have full control over your data structures, then you can always anticipate what happens. But here it's black box. You don't know what happens, so probably crashes as soon as you do certain things or undefined behavior, and maybe you run into this, maybe you don't. It sounds very risky. I guess the least that one has to do is always release on the same thread, right? You shouldn't just release somewhere else. Read source file for compiler. I assume it's fine if you just read from things, right? So here we just call get file name. That's probably okay, right? Because it's just reading. Hold on. This is allocating. Yeah, but maybe it's fine because it allocates just on the threads. Then you free it. So I guess as long as you don't change the state of this. So let's say you pass this to your job. And then you do all this, and here this, by the way, should be constant iterator. Yeah. Let's do it right here. And I think, yeah, let's make a pass here on the constants. I think that would make it a bit easier to see. So I think this will be const and this as well. Ah, no, because this is not const. Huh. Yeah. It's not const. Good old C API. Yeah, you don't know. Like, if it was a const function, we would have guarantee the contract, well, not guarantee, but the contract would indicate that if you call a const function that it doesn't write state of that object, right? I mean, it could still violate with const cast or mutable, but it would have some confidence. But here we don't have any confidence. Like even this could be dangerous in some way. I don't know. Okay, but yeah, so yeah, what we could do is spawn jobs for all sorts of small things. I don't know, but it could be dangerous. I don't know. Maybe read components. Like, for example, here on read compilants, like if we could jobify this whole thing so that one job reads one compilant as a whole, right? If that would work, that could significantly speed up things. Yeah. So I guess it's something we would just have to test and see if it crashes or not. But it sounds dangerous. And then obviously we would have to adjust those data structures. Like we would have to return a compilant to well, we need to, we would need we would need to have a thread safe vector or just a lock for the vector when we push to it. Yeah, then there will be lock contention eventually. We need a push vector. We need a data structure where we can just push data to efficiently. Yeah. But then the problem is if we just push from threads to containers, then things will be out of order. That's not good. But I guess we could always sort at the end of it. But that's also a bit expensive, sorting. Oof, yeah, multithreading is Multithreading is always complicated. It's hard to get right. Multithreading is hard in general. It's easy to make mistakes. Yeah, and it's easy. It's hard to get it like super performant. Like you have to be careful that you don't content your locks too often because that will put your threads to sleep. Don't want to do that. So lockless it is. Yeah. 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 Okay. Now we touched some things. Let's see if it still compiles actually. Yeah. Okay, so okay, for now, let's not worry about jobifying things. But we need to think about how we manage our threads, our worker threads. Yeah. Well, but for that we just need a simple thread. Yeah. Yeah, we just create a worker thread. We don't need a job system for that. We just use std thread and then we build some state between these with some atomic types. Yeah. Okay, so by default, the thread will just idle, will just not do anything. And then, yeah, we need to give it then some inputs, like the same way we do with the runner right now. So let's go to our runner. Here, runner. So currently it has these things. Yeah, so basically, so our thread would own the runner, and then we would pass to that thread these options thingies. This, for now, just these things. These things, this. And yeah. So we need to have a queue of some sort. Yeah, we need a action queue. Do we have C++ multi-threaded queue? Thread safe queue. We need the thread safe queue. Concurrent task queue. Thread safe queue. Thread pool. Yeah, I assume that concurrent queue. Concurrent queue. Yeah, we need a single producer, single consumer queue at least. Single producer, single consumer. That is one of those two. Single producer, single consumer, log-free queue. Yeah. Yeah. I think for starters, we have a single producer, single consumer queue between our UI and our worker threads. And there we just push like these options, right? Like please load this executable, please load this PDB, process this output or comparison, get it done. And then it will get to work, put it in the queue, queue is being picked up on the other side, and then it will work off this item. Then maybe we can have another queue where we can inform about cancellation if you want to cancel a certain operation. Yeah. Options. Yeah, I see that working. Yeah. Okay, so the runner runs on our consumer thread, and we just feed it from our producer, the UI thread. We just feed it those instructions here. Why is this public? Because it's called here. also need a queue back. Yeah, where the worker says, hey, this is now done. You can pick it up and use it. In our runner, it's yeah. So I need a callback. Do we need a callback? No, I think a queue is just fine. We just in the UI thread we just check the queue if there's something interesting inside. You could also have callback. Yeah. No, we can't have callback because that would call back on the wrong thread. No, we need a queue. Queue in both directions. So one queue for instructing the consumer to do something, the worker thread to work on runner, and then once the runner is done with something, then he gives the information back to UI thread. Hey, I have this ready now. And then UI thread can work on that. Yeah, okay. Okay, so we need some queues at forward states. And then they should be able to work autonomously. Basically, the data that once the data is populated on the worker thread, it needs to be read-only so that the UI thread can work with it, read it. It should be immutable at this point. It just sits there. Yeah. Just sits there. Yeah. Get exe file name from PDB. I think we need to get rid of this file index thingy here. Well, actually no, I think this file index is okay. But I think here these need to become vectors with stable references. So either this needs to be unique pointer. Yeah, unique pointer. Or how big is this? 432, 400. Yeah, so either yeah. Yeah, either we make it a vector of unique pointers of executable and PDB reader, or Or we use a PLF colony for this. Yeah. So basically the idea would be that we process exe. Yeah, I think we need to expand this functionality. Yes, output, let me see. Let's get that 0. Yeah. Okay, I think it's fine to work here with these indices. So, for example, what you can say is, okay, we request process exe with this, and then once this is done, it will return us the index to this exe, right? So index 0, well, that would be the first. So we don't actually pass it an index on first use. It gives us an index in return and a bool for success. And then we can, we know that then we always have the index to look up that thing that we have loaded. Yeah. And then we can use those file indices. Let's say we load 10 executables. Yeah, so we have from 0 to 9, we have file indices. And then we can use 2 of these and pass them, for example, to this comparison function. I want to compare file 1 with file 2. Yeah, and then you pass this here in the comparison options, for example. Yeah. No, I think it would be better as separate arguments. Comparison options. Yeah. Yeah. Mm-hmm. Yeah. Okay, this would mean that we can get rid of this hard limit here. Okay, so we need a vector of unique pointers, or we add PLF colony. Okay, so we need the queue object, queue template function. PLF colony, maybe it's a bit overkill for this. Basically, I want a container that has stable memory. It doesn't reallocate when it grows or shrinks when you delete something. So PLF colony can be used for this. But maybe unique pointer would be easier, but let me think, is there maybe a disadvantage? there could be. If you use a vector of unique pointers, it could run risk in scenarios where, let's say, we have one job. Let's say we have multiple workers, not just one. And one worker is reading an executable, and another is working with another executable at this time that is already in a vector. Hold on, but they are all... Yeah, okay, but you look... Yeah, it could be... Yeah, it could be a problem or it could be not a problem. If you just pass on the executable object that the unique pointer points to, then it's not a big deal. Then it's stable. But if you pass the index to threads, and then the threads operate with the index on this member vector, and then let's say one worker reallocates this while the other tries to access it and read it, then that would crash. And I think the colony would be resistant against this type of problem, but the colony cannot be indexed. The colony only has iterators. Yeah. But you can have pointers to the elements. Okay, I think the vector with unique pointers is okay. Yeah, let's go with a vector for now. If we need a colony, we can still change it later. Okay. Good. Then we certainly need the queue. We can get that. Yeah, okay. Okay, I have a rough plan now for our first iteration. Yeah. So basically, what we can do for starters is just provide the functionality that currently we can do per command line, right? It's like call these things the same way that it does here in the main function at the bottom, just with actual queue towards another thread. So this is all here done on one thread. It's fine. But for the UI, we need the second thread. So we have the queue. We push those options, the commands, and then we pick it up on the worker thread. Then we process sequentially on the worker threads. And for every chunk that is done, we give back a result. That the result is there, ready for pickup. And then, yeah, in the UI, we will then show some things about it. And yeah. Okay, I think that is a good plan. Okay. Yeah, I think we have a plan. It's next video, let's add find and add a queue, and also extend the runner to have here vectors of unique pointers, allow pushing unlimited amount of thingies here. Process X. Yeah, we should keep these separate, these two, but have the indices consistent. Yeah. Okay. Well, there won't be too much loaded anyway, so we're talking small numbers here. That's fine. Okay, good. Yeah, I will take a break now. Has been 2 hours 20. Yeah. All right, but we made a little bit of progress. That's good. We have a file dialog edit. We did a little bit of thinking. Yeah, one step at a time. One step at a time. Okay, all right. I wish you a great day or night. Until next time. Goodbye.